right, so let's get started on our last section for chapter 7. So we're still working with rational expressions, and in this section, we're going to be working with rational equations. So a couple things to review before we jump into some of those examples. First thing is that the difference between an expression and an equation is that expressions can be simplified, meaning we'd have something like 3/4 x minus 2/3 x. So we could simplify this and combine these terms together, while equations can be solved. So anything that has an equal sign is an equation. And so let's say we had 3/4 x minus 2/3 x equals 8. So this is an equation and we can solve it. We can say what x is going to be equal to. So that's our first little bit of review. Our second is something you might not remember all that well from Math 95 because we didn't work with it a ton. But if we wanted to clear fractions in an equation, we could multiply by the LCD. So let's go ahead and take a look at a couple of examples to see what that looks like. All right, so let's go ahead and look at 2/3 x minus 4/9 x equals 2. So we could go through and solve this equation by combining these x's on the left and then multiplying by the reciprocal. Another way to solve this, and this is a way that we're going to have to solve, or a method that we're going to have to use when we're solving rational equations with variables on the bottom of the fractions, we're going to have to multiply every single term by the LCD. Now, if we look at the LCD, we only have two fractions. We have this 2/3 and this 4/9. This is the same LCD that you would find if you were going to add these two fractions together or subtract them. So 2/3 and 4/9, our LCD is going to be 9. So now we want to go ahead and multiply every single term, even if it is not a fraction, by this LCD. So I'm going to go ahead and put this in on the left here. So we're going to have times 9/1. And then this 4/9, we're going to multiply it by, I'm going to move this minus sign, 9/1. And then on the right, I'm going to multiply this 2 by a 9. So all we've done so far, and I should have done this in a different color, is put in these 9s so that we're multiplying every single term by 9. That's our first step here. Once you do this, all of your fractions should be eliminated. So let's go ahead and take a look at what that looks like. So our first multiplication here, if you wanted to do this off to the side, you totally could. I'm going to do it here. I'm going to reduce the 3 and the 9. So 3 goes into 3 one time, 3 goes into 9 3 times. Now notice on the bottom that we only have 1s. So we have 3 times 2, which is 6/1, which is the same thing as just 6. So really when you're doing this, we don't care about the denominator as long as they're both 1s. So we get 6x minus, now these 9s just cancel out, and we get 4/1, which is just 4x, equals 2 times 9, which is 18. Now you should have a pretty nice equation with no fractions. So to solve this, we're going to combine our like terms on the left. So we get 2x equals 18, divide both sides by 2, and we get x equals 9. And remember, if we wanted to check this one, we would have to take this 9 and plug it back into the original equation before you multiply by the LCD, just in case you made a little mistake while multiplying by the LCD. All right, let's go ahead and try another example like this before we get into some rational equations. So this one, we want to go ahead and solve x over 6 plus x over 3 equals 6 plus x. So for this one, again, we have two fractions. This time the x is on top of the fraction, which is completely fine. It's the exact same thing. We want to go ahead and multiply this by the LCD. So what is our LCD for this one? Well, we have two denominators. We have a 6 and a 3, and the smallest number that they both go into is 6. So we're going to be multiplying every single term. Make sure I'll do this in a different color this time, by 6, or 6 over 1 for these fractions. Squeeze it in there. And then on the right side, you want to multiply both of these terms by 6. So you could write this two different ways. You could write it like this, where you put parentheses and multiply the entire side by 6, because that would need to be distributed in. Or the way that I'm going to do it is I'm going to go ahead and just write 6 next to each of these. That way you don't forget to distribute. All right, now let's go ahead and distribute, or not distribute, let's go ahead and cancel things out. So in this first fraction here, these 6's just cancel. So we get x over 1, which is just x, plus, and now this 3 and the 6, we can reduce this to a 1 and a 2. So looking on top, we have 2 times x, so 2x over 1, so just 2x. And then equals 6 times 6 is 36, plus x times 6 is 6x. Now let's go ahead and just combine like terms and solve this one. Should be a nice linear equation. So we'll combine on the left and we get 3x. So we had 1x plus 2x equals 36 plus 6x. The constants are all on the right, so I'm going to move the 6x over to the left. So we'll subtract 6x. And we get negative 3x equals 36. And then if we go ahead and divide both sides by negative 3, we get x equals negative 12. And again, you could check this by plugging it back into the original equation. All right, so now we're going to be doing the same thing, but we're going to be doing it with rational equations, which means we're going to have some variables on the bottom of the fraction. So it's going to be a little bit more complicated, but let's go ahead and write out the steps first for solving rational equations. So first thing you want to do is factor the denominators. Oops, that's an ORS. The reason for this is because we're finding the LCD, we're going to need to know the different factors. So this is going to help us find the LCD. It's also going to help us check for values that the variable cannot equal. So this goes back to that first section we did in 7.1. This is where we want to find what x cannot equal, because remember the denominator cannot equal 0. So we're going to be setting up an equation that's going to be the other difference between these rational equations and the original equations we were doing up here. Thirdly, you want to go ahead and find the LCD. And for this step, it doesn't matter which one you do first between 2 and 3. you do want to factor the denominators first, just because you're going to have to do that for both of these anyway. So I just do it first. But it doesn't matter which one you do out of these two first. I just like to find the variables that the values that the variable cannot equal first, just so you don't forget it. Because once you find the LCD, you're going to be multiplying every single term. And I'm going to double underline every, because it has to be every term, not just the fractions, by the LCD. So it's really easy to forget to find the values that the variable cannot equal. It's really easy to forget that step. So I like to do that before I find the LCD, because from the LCD, you're going to multiply every term by the LCD. All right, so let's go ahead and try a couple of examples here. And so we're told to solve. Because they're equations, we can find what x is equal to. All right, so this first one here, this one is kind of similar to what we just did, but I want to show you this one because it has some distributing in it. So we're given, and I'm going to leave some space on the left here, 2m minus 3 over 5 minus, again, I'll leave a little bit of space because we know we're going to be multiplying, m over 3 equals negative 6 over 5. All right, so first things first, looking for the values for the variables that in this case m cannot equal. Well, if we look at our denominators, we know that the denominators cannot equal 0, but here we have a 5, we have a 3, and a 5. For this one, those are our denominators, and those are set in stone because there are no variables down on the bottom with those numbers. So in this case, m can be any number. The only time you'll have those kind of restricted values is if you have a variable in the denominator. So we'll see those soon, but we don't have any restricted values for this one. So now we can go straight to our LCD. And so our LCD for this one, just like before, there's no factoring to do because we only have numbers. The LCD for 5 and 3 is 15. So let's multiply each of these terms by 15 over 1, 15 over 1, and 15 over 1. And now for this one, this first term is where you have to be careful. So if we go ahead and reduce the 5 and the 15 to a 1 and a 3, we're taking this 3 and we're multiplying it by 2m minus 3. Anytime you have addition or subtraction, I would throw parentheses around that group because we're going to have to distribute. I'm going to bring this down and distribute in a second in our next step. So we're going to have 3 parentheses 2m minus 3. Bring down this minus, and now we can reduce the 3 and the 15 here to a 1 and a 5. So then we have 5 times m, which is 5m. And notice at this point, I'm just ignoring the denominators because they're always going to be 1s, assuming you're multiplying by the LCD. And now on the right here, we have a 5 and a 15, so that reduces to 1 and 3. And so we have negative 6 times 3, which is negative 18. And now we have a nice linear equation to solve, so let's go ahead and distribute. And we get 6m minus 9 minus 5m equals negative 18. Let's combine our like terms here. So we get m, or 1m, minus 9 equals negative 18. And then let's add this 9 to both sides. And we get m equals negative 9. Now, we didn't have any values that m could not equal, so this is our solution for this one. All right, let's go ahead and try another one, and let's introduce some variables in the denominator. So let's go ahead and let's see which one I want to do first. Let's do this one first. All right, so number 2 here, we're given 4 over x squared minus 3x equals 1 over x squared minus 9. And now first thing I'm going to do here is I'm going to factor the denominators. Now I'm going to go ahead and actually rewrite this equation. And I'm going to do it off to the right because I didn't leave myself a ton of room. So I'm going to move this over here, and I'm going to put the factored denominators in our equation. That way canceling out is going to be a little bit easier. You'll see what I mean by that once we start actually canceling out. So let's look at this first denominator, this x squared minus 3x. We can take an x out of there, and we're left with an x minus 3. That's all we can do, so let's rewrite this as 4 over x times x minus 3 equals, now on the right side here, x squared minus 9 is the difference of perfect squares. So we're going to have 2 sets of parentheses. X squared is x times x. 9 is 3 times 3. Put in your plus and minus. So we have 1 over x plus 3, x minus 3. Remember, the order for the plus and the minus doesn't matter. Now we can go ahead and find our LCD. So if we look for our LCD here, we're looking for our different factors. So if we go ahead and look at both of these, we have an x minus 3. And I'll erase these lines in a second just so they don't throw us off. But we have an x minus 3, and we need one of those because we have 1 in each of them. And then we also have these other 2 factors. We have an x plus 3 here, one of those. And then we also have an x right there in the front. So we do need to include that x. I'm going to put it in the beginning of our LCD here. And now there's one step which we didn't do. That was step number 2. If we go back to our list here. Remember, it doesn't matter what order you do these in. So I found the LCD first. Now I'm going to find the values that each variable cannot equal. So what we're going to do for this step is we're going to take each one of our denominators, and this is a lot easier now that it's in factored form. You'll probably get into the habit of doing this without even writing it down, but let's go ahead and write this one down. What we're going to do is, I'm going to do this up top here. So we're going to take each of our denominators. So let's start with the one on the left. So we're going to say x times x minus 3 cannot equal 0. We know that we cannot divide by 0. Because it's in factored form, remember if you go back to your knowledge about quadratic equations, we're going to split this up into 2 equations. Our first one is this x out in front, so we get x cannot equal 0. That's already one of our values, so I'm going to add that over here. And then if we have x minus 3 cannot equal 0 and solve this for x, we get x cannot equal 3. So I'll add that to the list down here. And now if we do the same thing with our other denominator, we have x plus 3 times x minus 3 cannot equal 0. Splitting this one up, we have x plus 3 cannot equal 0. Subtract 3 from both sides. We get x cannot equal negative 3. Add that to the list. And then our other one, we have x minus 3 cannot equal 0. And now if you notice, this is exactly the same as what we had over here. So if I were to go through and solve this one again, we would get x cannot equal 3. So anytime you have any of those kind of repeating factors, you don't need to write them in your list twice because we've already covered that 3. So we're just going to leave our list as is. So x cannot equal 0, 3, or -3. If we got any one of those as our solution, we would not include that. So you'll see some examples soon where we'll either end up with no solution or we'll kind of have to cross one of them out. All right, now let's go ahead and start multiplying everything by the LCD. So this is the part where it gets kind of weird with these rational equations. I'm going to multiply, we only have two fractions here, two terms. We need to multiply both of these by the LCD. I'm going to move this arrow a little bit further to the left, and I'll change the color. There we go. Now, let's go ahead and multiply each of these by the LCD. Remember, our LCD is x times x minus 3 times x plus 3 over 1. And then we'll do the same thing on the right. So x times x minus 3 times x plus 3 over 1. Always leave yourself plenty of space. I'm kind of running out here. The more space you have, the more organized it's going to be and the easier it's going to be to see the answers. So first thing we want to do here now is cancel out any of these factors we have in common. This is just like a multiplication problem you've seen back in 7.2. So we can cancel out these x's, cancel out these x minus 3's. Now notice on the bottom you only have a 1, so we can ignore that. And on the top we have x plus 3 times 4. So I'm going to leave that as 4 times x plus 3, and I'll distribute in the next step. Equals, now on the right, we can cancel out this x plus 3, this x minus 3. And again, you should notice those factors on the bottom are canceled. If they're not, then this wasn't the LCD. Now we're left with a 1 times x, which is just x, over 1. And we don't care about that 1 in the denominator. All right, now we have this nice, simple linear equation. Let's go ahead and distribute. So we get 4x plus 12 equals x. I'm going to go ahead and move all the x's over to the right. So let's subtract 4x. And we get 12 equals negative 3x. Divide both sides by negative 3. And we get x equals negative 4. Before you box your final answer, now our tests aren't going to be on paper, obviously, but just to kind of get in the habit of doing this, I wouldn't box your answer until you double check what x could not equal, because you're going to be typing these answers into MyMathLab, and you always want to make sure that you don't type in an answer that doesn't work. So if we double check our answers over here, x could not equal 0, 3, or negative 3. We got x equals negative 4, so this is perfectly fine. So this is our solution. Okay, let's go ahead and try some more of these. Number 3. Let's go ahead and do solve the equation 1 minus 2 over x plus 1 equals 2x over x plus 1. All right, so for this one, if you notice, our denominators are already factored. Well, they can't be factored. We have an x plus 1 and an x plus 1. I'm just going to put those in parentheses. And this also makes our LCD really nice and easy because there's no factoring to do, and they're the exact same denominator, which means our LCD has to be x plus 1. Now we want to find what x cannot equal. Because these denominators are exactly the same, I'm just going to set one of them equal to 0. Say x plus 1 cannot equal 0. Subtract 1, and we get x cannot equal negative 1. So if we get negative 1 as our solution, we are going to get rid of that one because that doesn't work. And now let's go ahead and multiply every single term, including the terms that are not fractions, by x plus 1. So with this first one here, we have a 1 in the front. It's not a fraction, but we do have to multiply it by x plus 1. And then we're going to multiply these two terms here by x plus 1. I'm going to move this equal sign to the right a little bit. So I'm going to put x plus 1 in parentheses on the top, and it's technically over 1. If you want to start leaving that over 1 off, you can, because we never include the denominator of 1. Same thing on the right, we're going to put in that x plus 1. Again, leave yourself plenty of room because I am not doing that. Over 1, there we go. So let's go ahead and start multiplying. We have x plus 1 times 1 on the left here. X plus 1, or any term or expression times 1 is itself, so this is just x plus 1. And now minus, in this term here, these x plus 1's cancel, and we're left with 2 over 1, which is just 2. On the right, we have x plus 1's canceling, and we're left with 2x over 1, which is just 2x. All of our denominators are gone, and we should be able to just simplify this down. So let's go ahead and combine our like terms. So we have x, 1 minus 2 is minus 1, equals 2x. Let's move all of our x's to the right. So subtract x from both sides. And one thing, just kind of throw in a little note here as we work through this, I would pause as you start to get more comfortable with these. Pause, it doesn't have to be in the first step when I write down the problem, but if you want to pause, maybe when we're multiplying by the LCD or part of the way through the problem, just to see if you can kind of finish it off. That way you know how well you're grasping this stuff and if you need to ask any questions. All right, back to the problem here. So we got rid of the x, so we have negative 1 equals 2x minus 1x is x. So we have x equals negative 1 here, but if we look at our restricted value here, x cannot equal negative 1, because if we plug in this negative 1 into our original problem with the x plus 1 in the denominator, we would get 0. We can't have 0 in the denominator, so this one does not work. Anytime it doesn't work, we say that we have no solution, because we don't have any other solutions for x that would work. Let's say we were doing a problem where you got x equals negative 1 and x equals 1. So if you had 2 solutions for x, you would just cross out the negative 1, but you would have one solution still. Since this is our only solution here, then, and we had to get rid of it, then we have no solution, or we write it as the empty set. These both mean the same thing. On my math lab, it's going to use this right here. And this just means empty set, which just means our solution set is empty. Okay, let's go ahead and try another one. And debating whether I want to put this one on the same sheet. I'm going to move this one to a different sheet just so we have plenty of room to go through and do this. Okay, what number was that? That was 3, so we're on 4. Number 4. I'm going to give myself some room for this one, but we are going to have to do some factoring here. So I'm going to write this one as 8r over 4r squared minus 1 equals 3 over 2r plus 1 plus 3 over 2r minus 1. Okay, so for this one, first things first, we want to go ahead and do any factoring in the denominators that we can. We do have this one right here to factor. So let's go ahead and factor this first one. So we're going to have 8r over. Now, if you notice 4r squared and 1 are perfect squares, so we're going to have two sets of parentheses here. 4r squared, well, 4 comes from 2 times 2. R squared comes from r times r, so we have 2r. 1 comes from 1 times 1, so 2r plus 1, 2r minus 1. And sometimes you can look at the other terms to kind of get a hint for that. Notice how both of these are the two factors. They should have something in common. And now on the right here, these cannot be factored, so I'm going to leave this as, I'm going to leave a little bit of space here actually. I'll leave it after. So 3 over 2r plus 1, I'm going to throw that in parentheses because we know we're going to be canceling, plus, I'll leave some space, 3 over 2r minus 1. Okay, now let's go ahead and figure out, remember two things. We want to know the LCD, and we also want to know what x cannot equal. So if we look at our denominators here, let's do what x cannot equal first. We have 2r plus 1 times 2r minus 1. So 2r plus 1 times 2r minus 1 cannot equal 0. And now our other two equations, or two fractions here, 2r plus 1 in the denominator, 2r minus 1 in the denominator, those are already included in this first denominator here. So I don't need to do that work twice. We're just going to work with these two factors here. So let's split this equation up. 2r plus 1 cannot equal 0, and 2r minus 1 cannot equal 0. And now let's go ahead and subtract the 1 on the first equation. So 2r equals -1, sorry, cannot equal. And divide both sides by 2. So we get r cannot equal -1/2. And I normally leave things as fractions because changing things to decimals is not good unless it's a perfect rounded decimal. Like this one would be -0.5. That's fine. Fractions are just a little bit easier to work with equations. And I put x over here. I meant r. Okay, and then in our other one here, 2r minus 1 cannot equal 0. Let's add 1. We get 2r cannot equal 1. Divide both sides by 2, and we get r cannot equal +1/2. So we have our two values that r cannot equal. If we get either of those, they will not be part of the solution set. Now let's go ahead and figure out our LCD. We have a 2r plus 1 that occurs once in either of these fractions, or in each of these fractions. So we need to include 1 2r plus 1. And we also have 1 2r minus 1 that is included in each of these two. So we need to include one of those. And those are only two factors. So our least common denominator here is 2r plus 1 times 2r minus 1. All right, so now let's go ahead and multiply by our LCD. So we have 2r plus 1 times 2r minus 1. And I'll put it over 1, but again, you don't have to. I'm going to squeeze it in here. And squeeze it in over here. Half the time I'm going to be kind of slanting these upwards so they can squeeze in. All right, now let's go ahead and see what cancels out. So in this fraction here on the left, 2r plus 1 and 2r minus 1 cancel. So we're just left with this 8r over 1, which is just 8r, equals. Now in this second fraction here, we can cancel out the 2r plus 1s. And what are we left with? Well, we're left with a 3 times 2r minus 1. So I'm going to put 3 parentheses 2r minus 1 plus. Now let's see what we can cancel here. We can cancel out the 2r minus 1s. We're left with 3 times 2r plus 1. And again, I would leave to distributing until the next step because we will see an example where there's a minus sign in the middle, which means we'll be distributing a negative. Be really careful on that one. All right, let's go ahead and distribute now. So we're going to have 8r equals 6r minus 3 plus 6r plus 3. Let's do a little bit of canceling here, or combining like terms, I mean. So these 6r's combine, so we get 12r. And then this is why I said canceling, because we have a minus 3 plus 3. Those give us 0, so we do not need to write down 0 here. We'll just kind of cancel those guys out. And so we have 8r equals 12r, which looks weird because we don't have any constants. We still want to get our r's on one side. So let's go ahead and move, I'm going to move the r's over to the right to keep them positive. Subtract 8r. Now on the left side, 8r minus 8r is 0. On the right, 12r minus 8r is 4r. And now if we divide both sides by 4, 0 divided by any number is 0. So r is equal to 0. Let's double check our restricted values over here. Neither of these is 0, so this is our solution. So getting 0 is a perfectly acceptable solution as long as when you plug it back in, you do not get 0 in the denominator, which we would not if we plugged it in up here. Okay, let's go ahead and try one more. The section's a little bit longer than others because we do have a little bit to do after this, but I want to make sure that we look at this next problem here. So for this one, we're given 3. Is this the one I want to do? Yeah, okay, so we have 3 over m squared minus 9 equals 1 over 2 times m minus 3 minus 1/4. Okay, so first things first, let's go ahead and see if everything is factored. It is not because we have this guy right here. So let's go ahead and rewrite this. So we're going to have 3 over m squared minus 9 is the difference of perfect squares. We're getting a lot of practice with these today. You could also have trinomials here where you have to use the big X. We haven't seen any of those, but it's definitely possible that you could get those. You would just have to factor like normal. So m squared minus 9, you would factor into your 2 sets of parentheses. We have an m times m for m squared, 3 times 3 for the 9, plus or minus, so m plus 3 m minus 3. This one's already nicely factored for us, so 1 over 2 times m minus 3. I'm going to leave a little bit of space, and then minus 1 over 4. Now let's go ahead and figure out, we need our LCD, and we need to know what m cannot equal. So let's do our LCD first. This is kind of a nice habit to get into, writing out your LCD and m cannot equal. That way it's just a reminder to yourself that you have to do these two things, even if we're not doing them both right now. You know that you have to do them at some point. All right, so our LCD, we have an m plus 3 here, and that's all we have for that one. So we need to include an m plus 3. And now we have an m minus 3 in both of these, so just 1 in each. So we include 1 m minus 3. And again, if you by accident include 2 of them, it would still be correct. You would just have more work to do as you go through. You'd probably end up with a quadratic equation, which would make solving these a little bit harder, but still doable. Let's see what else we have. This is the part that's kind of weird. We have a 2 and a 4. So these are both constants, which is why I underlined them together. Now, think about regular fractions. The LCD, if we had just 2 and 4, would be a 4. So that's just regular LCD working with numbers. So you kind of put those two together. Okay, so that's our LCD. Now let's go ahead and talk about what m cannot equal. So let's take our first denominator here. So m plus 3, m minus 3, and say that that cannot equal 0. If we split that up, we get m plus 3 cannot equal 0, and m minus 3 cannot equal 0. So solving our first one here, we get m cannot equal -3, so I'll put that in our list. Our next one, add 3 to both sides, we get m cannot equal 3. Let's add that to the list. And now if we look at our other denominators, this one here we have 2 times m minus 3. Now, if I were to write that out as 2 times m minus 3 cannot equal 0, what you can do here, kind of like what we do when we split up the factors, well, 2 different things you can do. You can think of this as when you split it up, we would have 2 cannot equal 0 and m minus 3 cannot equal 0. Well, m minus 3 was taken care of up here, so we don't have to do that one again. And 2 cannot equal 0 is just a true statement. That doesn't tell us anything about what m can equal. So we're just going to ignore this one, and we can ignore this guy too because we've already taken care of that. Same thing with this 4 over here. There's no m in that denominator, so we don't care about it. So we didn't really need to do this step here as long as you've taken care of the factor there with the variable in it in one of your other denominators. All right, so our restricted values are taken care of. Let's go ahead and multiply everything by the LCD. So we're going to multiply over here by 4 times m plus 3, m minus 3 over 1. Multiply here by 4 times m plus 3, m minus 3 over 1. And right here times 4, m plus 3, m minus 3 over 1. All right, so now let's go ahead and cancel. So on the left side here, we can cancel out m plus 3, m minus 3, and we have 4 times 3, which is 12, equals. Now over here, we can cancel out these m minus 3s. And now looking at the 2 and the 4, we can reduce this to a 1 and a 2. Now, if we see what we have left, we have nothing on the bottom, which is good. On the top, we have 1 times 2, which is 2, times m plus 3, so parentheses m plus 3, minus, I'm bringing down this minus sign here. Our 4's cancel, and that is it. So we still have m plus 3 times m minus 3, and I am going to bring this down here. And this is one, whoops, where you have to be careful with this minus sign. So if we go ahead and start simplifying a little bit, we have 12 equals, distribute the 2, so we get 2m plus 6. And now here, I'm going to go ahead and FOIL this out, but remember that we're subtracting this whole product. So I'm going to keep the subtraction, keep a set of parentheses, and FOIL. So m times m is m squared. M times -3 is -3m. 3 times m is plus 3m. And then 3 times -3 is -9. We're subtracting that entire product, so we want to go ahead and distribute this negative in to every single one of those terms on the inside. So we have 12 equals 2m plus 6 minus m squared. Negative times a negative is a positive 3m. Negative times a positive is a negative 3m. Notice how all the signs are just changing. Negative times a negative is a positive 9. Now let's combine like terms. And one thing I want you to notice on the right is that we had a 3m and a negative 3m. Those guys give us 0. And we have a negative m squared. I'm going to put these in descending order, meaning the highest exponent first. We have a 2m and it's positive, so plus 2m. And then we also have a plus 6 and a plus 9. That gives us a plus 15. All right, now let's go ahead and see what we have here. We have a quadratic equation, which means that we want this to be equal to 0 so that we can factor and solve. So in order to make this a little bit easier for factoring, I'm going to make this m squared positive by moving it over to the right, or sorry, to the left side. So I'm going to add m squared, and it's just going to kind of go in the front. So we're going to have a positive m squared. I'm going to move this 2m over to the left, so minus 2m. Again, nothing to combine it with, so minus 2m. And then minus 15. That we can combine with the 12. So we get minus 3 equals 0, because we got rid of all of those terms. That was our goal. Now let's go ahead and factor. So we have a trinomial, so big X. We're multiplying to negative 3, adding to negative 2. And let's see, multiplying to 3, we need a 3 and a 1. It's a negative 3, so we need positive and a negative. Because we're adding to a negative 2, we need a negative 3. So m minus 3 and m plus 1 equals 0. Split this up. So m minus 3, m minus 3 equals 0 and m plus 1 equals 0. Solve each of these. So we get m equals 3. I'm not boxing it yet because we want to double check our answers. And m plus 1 equals 0. Subtract the 1. We get m equals negative 1. Now, if we double check our answers, we had a negative 3 and 3 that m could not be equal to. Notice that we got m equals 3 as one of our solutions. That does not work. So our only solution here is m equals negative 1. We're not going to put no solution because we still had one solution that worked. The only time you put no solution is when both of them do not work. All right, now the last little part of this section, and we're just going to do a couple of examples here, is solving a formula for a specified variable. And now this is something, again, that you've seen before, you just haven't seen it with rational expressions, so variables on the bottom. So this first one here, we're told to solve r equals a minus p over pt for a. Now we know our goal is to solve for a, so what we need to do here is we first, just like we were just doing, is get rid of the fraction by multiplying by the LCD. And there's no restricted values here because we have so many variables here. If we said our denominator could not equal 0, this would just mean p does not equal 0 and t cannot equal 0. But we're not going to get actual numerical solutions. We're going to get solutions with variables in them. So we're going to ignore that step. We're going to just multiply by the LCD. So our LCD here, we only have one denominator, so our LCD has to be PT. Let's go ahead and multiply both sides by PT over 1. PT times R, there isn't any actual solving we can do here. We're just going to put PTR. But on the right side, the PTs cancel, and we're left with A minus P over 1, which is A minus P. And the only thing left to do, since we're solving this for A, our goal is to get A by itself. We want to go ahead and just add this P to both sides. And PTR and P are not like terms because this first term has a T and an R. This one does not. So we're just going to put PTR plus P equals A. And your solutions here are going to look ugly, but this is exactly right. All right, let's try two more. This next one. Actually, let's go ahead and just do one more of these because that next one was pretty similar. So this next one, we have 2 over x equals 1 over y plus 1 over z. Now, again, we don't care about our restricted values because we don't have any. We need to find our LCD and then multiply everything by the LCD. We have 3 different factors here. We have an x, a y, and a z. Because they're 3 completely different factors, we're just going to include those in our LCD. So our LCD is x, y, z. So it makes it super nice. And then let's multiply every single term by x, y, z. You can put it over 1 if you want. And I'm going to have to squeeze it in here because I did not leave any room. And on the left side, it's nice and easy. I'll put it over here. All right, now we should be able to cancel some things out. So we can go ahead and cancel out the x's on the left. We're left with yz times 2, or 2yz. This is why I crossed my z's so I don't mix them up with my 2's. Normally I write my 2's a little differently, but I've started switching it up for some reason. Now on the right, we can cancel out these y's, and we're left with 1 times x times z, which is just xz. And then we have 1 over z times xyz, cancel out those z's, and we're left with xy, so plus xy. And I forgot to say what we were solving for here. We're solving for x. So since we're solving for x, we want all of our terms with an x in them to be, I'm sorry, let's not solve for x. That one makes this one a little bit easier, which is fine, but I want to make sure that you guys see the harder case. The reason for that is, let's solve for z. If we were solving for x, we want our, all of the terms with the variable that we're solving for to be on one side. If we were solving for x, all of the x terms are on the right already, so there's kind of a step missing. To make this a little bit trickier, let's solve for z. And so we want all of our z terms on one side and all of the other terms on the other. So notice how this term and this term both have a z. This one does not. So we want to get these first 2 terms on one side. Let's move the xz over to the left. So I'm going to subtract xz. And again, because we're combining it with yz, these are not like terms. So we're going to have 2yz minus xz equals xy. Now let's go ahead and see what we have here. So all of our z terms are on the left. This is the part where it gets kind of weird. You want to factor out the z. That's how we're going to separate the z from these two terms. So if we factor it out, we're left with 2y minus x equals xy. And now let me rewrite this up here just so you can see it a little better. Since our goal is to solve for z, I want to get rid of this 2y minus x, so we're going to divide both sides by 2y minus x. Those cancel on the left, so we're left with z equals, and now on the right, you're going to leave it just like this, xy over 2y minus x. So those ones are pretty common. You'll see ones where you have to get those z terms on one side and factor out the z. You will see some of those on your homework, so just make sure you kind of remember that trick. That'll normally happen when you have an LCD where it's like x, y, z kind of thing. All right, so that's chapter 7. We are finally done with rational expressions, which is good because that is one of the hardest chapters of this class, in most people's opinion anyway. Next, we're going to be getting to some a little bit of review actually from Math 95, so it should be a nice break. And generally, chapter 8 is not too bad. So that's our next chapter we'll be going through is chapter 8.